Okay, so today we're going to look at part one of transformations of functions. So some graphs of common functions that we have talked about is the constant function, so our horizontal line, and the identity function, so anything that's linear. Okay, so we talked about these in 2.3 and 2.4. Okay, now we're going to be looking at the absolute value function. Okay, so remember the absolute value function shape is a V. Domain, range, decreasing, increasing, and even. Okay, are all listed there for you. So if we look at the absolute value function, f of x equals a times the absolute value of x plus h plus k, where a does not equal 0 is an absolute value function. So we're going to start off with just making an xy table to determine the graph of the function with our domain values from -3 to +3. So if we do this, the absolute value of -3 is 3. The ordered pair is -3, 3. Absolute value of -2 is 2. So we have the ordered pair -2, 2. The absolute value of -1 is 1. So we have -1, 1. The absolute value of 0 is 0. The absolute value of 1 is 1. So we have the ordered pair 1, 1. The absolute value of 2 is 2. So the ordered pair 2, 2. And the absolute value of 3 is 3. So we have the ordered pair 3, 3. So if we graph this, each of those ordered pairs that we just found, okay, we get a V-shaped graph. Ooh. Let's try that again. Okay. So now we can look at this, find the end behavior. For end behavior, we're simply going to just use arrows. So our end behavior is up, up. Our domain, since we go from the far left to the far right, is -infinity to +infinity. The range, our bottommost y value, is 0, going up to infinity. So 0 to infinity. Axis of symmetry is going to be the line that cuts the graph in half, which here would be the line x equals 0. The vertex is our bottom or topmost point of a graph. So here our vertex is going to be the ordered pair 0, 0. X-intercepts is where it crosses the x-axis. So here it's 0, 0. And then our y-intercept is where it crosses the y-axis. So 0, 0. All right, so now we are going to look at our translations. So the first one we're going to look at is our vertical translations. So here we have a picture of 3 different graphs. So we have our parent function, f of x equals the absolute value of x that we just graphed. We know that that graph goes through the origin. So that's going to be this red middle line. And now let's figure out which one is g of x and which one is h of x. So g of x equals the absolute value of x plus 2. So if we look at our 2 graphs, this one is 2 up, and this one is 4 down. So that means the top one is g of x, which is the absolute value of x, then plus 2. And the bottom, since it's down 4, must be h of x, which equals the absolute value of x minus 4. So we can give a general form for this, and that says the graph f of x equals the absolute value of x plus k is a translation of f of x equals the absolute value of x. Let C, and this should actually be a k, sorry, be a positive number. The k value translates the graph vertically by moving it up or down. If k is positive, our graph moved up. And if k is negative, our graph moves down. Okay. Now we're going to use that same idea for looking at horizontal translations. Okay, so graph below are the absolute value parent functions. F of x equals the absolute value of x, which we know is our red line here. And then we have the g of x equals the absolute value of x minus 3. And h of x equals the absolute value of x plus 1. So notice the blue line is 3 to the right, and our green absolute value is 1 to the left at -1. So that means the blue one is g of x, absolute value of x minus 3, and h of x is our green. Okay, so the graph f of x equals the absolute value of x plus h is a translation of f of x equals the absolute value of x. Let h be a positive number. The h value translates the graph horizontally by moving it left or right. If h is positive, then the graph moves. So notice here, when h was positive, so we were adding 1, our graph moved to the left of the origin. And if h is negative, then the graph must move right. So remember, horizontal translations are always backwards. Whoa. Sorry about that. What backwards? There we go. All right. So combine your translations. State what type of translations are occurring, then graph the function. So I want you to go ahead and try this example, and we will review it in class tomorrow. All right, vertical stretch or shrink. So we have a couple of different things here. Okay, so now we have 4 different graphs. So we have our parent function, f of x equals the absolute value of x. Remember, that's the one that goes through the origin. And it had a slope of 1. Okay, remember we went through the point 1, 1, 2, 2. So I'm going to label that. That happens to be our green one on this graph. We have g of x equals 3 times the absolute value of x. H equals 1/4 times the absolute value of x. And j of x equals negative absolute value of x. So if we talk this one through, let's start off with the one that's obviously different. J of x equals negative absolute value of x. It's our graph that's facing down. Okay, so we can go down here to this bottom little fact. If a is a negative number, so the number in front is negative, then the graph of f of x equals the absolute value of x is reflected across the x-axis. Okay, or remember that we've also talked about it, it's facing down. Okay. All right, so now let's look at the other two that we have here. So g of x equals 3 times the absolute value of x, and h of x equals 1/4 times the absolute value of x. So g of x is multiplied by 3 for the absolute value. So that's going to actually make it taller. If we look here, we start at our origin, we go up 1, 2, 3, and to the right 1, we get another point. Okay. So this red line is our g of x, which equals 3 times the absolute value of x. This is called a vertical stretch. It stretches your graph up. And then our blue line, h of x, equals 1/4 times the absolute value of x. If we start at our origin, we go up 1 to the right 4, we get our first point. Okay, so that's called a compression, or it shrinks the graph. Okay, so if we combine all that together, the graph f of x equals a times the absolute value of x is a translation of f of x equals the absolute value of x. Let a be a positive number. The a value translates the graph by stretching or compressing the graph. If a is greater than 1, then the graph is stretched. I'm going to write vertically. And if a is less than 1, the graph is compressed vertically. Okay. With absolute values, this is the only graph or only function where the value of a is the slope of the graph. It's the only one where we can use the idea of slope. All right, so I want you to try this example where we're going to kind of combine it all together. And then for these two examples, I want you to go ahead and write out what are the translations for each one. Okay, I want you to write those out for both of these graphs, and then we'll come up with the equation tomorrow as a class.